All right, example 3, really, I'm not going to do any math with this one at all. We're really just going to look at a definition of closure. Um, I think the explanation in the book's pretty complicated. Or a little more confusing than it might need to be. I'll walk through it in a second, but basically what you need to know is that an operation has closure if when you have two separate polynomials and you do that operation, you're guaranteed to also get a polynomial. So the answer to this question would be yes, pretty clearly. So the set of real numbers is closed under addition if a and b are real, and a plus b equals c, and c is also real. So you have two examples of polynomials here. When you add them together, the result is still a polynomial. So here you have an example where you have two terms, like terms. When you add them together, you just add the coefficients together and you have a new term. All of them are real. All of them are polynomials. So the fact that you had two things, you add them together, and it still is a polynomial means that operation has closure. And then same thing's happening for all of them. So since a and b are real, a plus b is also real. The exponents are unchanged. The sum is still a polynomial, so the set of polynomials is closed under addition. Using that exact same logic, you can determine that the set of polynomials is closed under subtraction. So for number 3, the try it here for number 3. It's just asking, is it closed under multiplication? Basically, all the same logic. I'm not going to pause it and have you come back. Let's just talk about it real quick. Same logic holds, right? If you have two polynomials and you multiply them together, the result is going to be a polynomial. You can make it more complicated than that, but that is the bottom line, right? So the answer is yes. And that's the explanation. Same logic that we just talked about for addition and subtraction. All right, let's look at example 4.